So I want to do exercise 3 in 2 different parts. I want to go over what the bird should do, the basic bird behaviors, go over some reminders of how animation works in JavaScript, and then stop the video and let you try to implement the behaviors yourself. Then they'll have a second video where I actually build up the behaviors and you'll be able to move on from there. I hope you actually take some time to try it. Actually try to code out these behaviors. Is not that difficult. It's a couple different things, and I'll give you some tips so that you know all the pieces that you need, and you'll have the video to fall back on if you can't quite figure it out. So looking at the bird, it is a circle. It starts out in the middle of the screen, and there are 2 behaviors it has because it matches with the 2 states of the game. In the pause state, it has this cyclical movement up and down, and it's just kind of waiting. And in the playing state, gravity is applied and it jumps when you tap. So if I tap, the game switches into the playing state and gravity starts applying and just falls. I have to refresh the page because it took away all the hit detection. So it falls and just keeps going potentially forever until I refresh the page. If you continue to tap, it jumps. And it jumps in this kind of natural-like fake physics where it goes up and then it slows down, it reaches a peak, and then it falls faster and faster as it goes down. Gravity is an accelerating force, so the bird should actually get faster the farther it falls. So let's look at exercise3.js, which should look a bit familiar. We have the game object, kind of bare bones here, but it's the way it ended up last with starting out in the pause state. It has our 3 steps for the loop. The loop is being run in the draw function, and it draws the background every time before it draws anything else so that it gives the illusion of motion. There's a new bird object that has the 2 important functions here, the update and the draw, and nothing else so far. So what do we need the bird to do? Well, to start with, it's a circle. So let's draw a circle in the draw. And we need to know where to draw it, and we need to know how big it should be. And I would store these, the variables for these as properties of the bird object. Just like we had in the circle example, and previously we had an x position, so we can have an x. I'm going to set it to the inner width divided by 2, so that's actually halfway between the left and right edges. I'm going to do the same thing for the y. Set it to the inner height divided by 2. And so when I draw this, I can reference those properties with this .x and this .y. And for now, I'm going to give it a height and width as numbers here, but that will change after a while. So the bird now has x and y properties to determine where the ellipse is drawn. And now we need to wire that up in the game. So let's go down here to draw, and after we draw the background, let's do bird.draw. And we'll pass in the game state in case we want to make any changes to what it draws when it gets here. So drawing shouldn't have any logic in it. Drawing shouldn't do too much calculation, because the calculation should already happen in update so that the react step has a chance to figure things out, figure out what the next thing to do in the game. So draw should be relatively dumb. The only thing I can think of doing right now is I might go ahead and write fill here, and just in case someone else, some other part of the game has changed the fill, let's set it back to black before we draw the ellipse. So go to exercise 3, we see the circle right here, and it's drawn. It's being drawn repeatedly again. You can't tell because it's not changing, but it's being drawn here. So we've already seen, you can change the x, or maybe let's do y, because that's the direction the bird will move. It doesn't move in the x direction. The x direction comes from the obstacles, which kind of makes it look like the bird's moving. So let's just change the y by 3 every step. And not going to do anything because I forgot to wire it up. The update step has to run inside the game's update. So let's do bird.update, pass in the game state, and then now refresh. And so it falls with a steady 3-pixel constant motion. So that doesn't look like gravity. That looks like it's just moving. That's because it's not accelerating. Again, this is, you can kind of think of this as speed like you would in a car, where you're going 3 pixels per frame. It's the same thing where miles per hour is a distance over a time period, and pixels per frame, pixel would be the distance, and frame is maybe not even the right word, but it's a representative of 1/60th of a second, which is how fast P5 runs the update. So 3 pixels for every 60th of a second is pretty fast, but not too fast. But it's a constant speed. What is acceleration? It's been a long time since I've taken a physics class, but I know that the general thing is that acceleration is, like for instance, gravity's acceleration is 9.8 meters per second per second. So it actually gets faster by 9.8 meters every second. So actually, sorry, it gets faster by 9.8 meters per second every second that something is moving. So instead of changing by a constant, we want to change how much it's changing, if that makes any sense. I can kind of illustrate it better. If I say, let's actually store a new property here and call it y acceleration. I'm going to start it at 0. And so if I have an acceleration of 0, I can take the speed and calculate something else here. I can do this y acceleration. Let's add very small amount, 0.1. And then instead of 3, let's add acceleration. So you see there's 2 operations here. One is we're moving the circle because we're changing the y value that we're using to draw. But we're also going to change every time update is run, y acceleration will get a little bit bigger. I use a small number here because it actually can get big pretty fast. So, well, that wasn't actually demonstrative enough. Let's use a slightly bigger number. So that got a lot faster really quickly, right? So the very first step, it moved by only half a pixel. But then the next time it moved by a full pixel. And then it moved by a pixel and a half. And then a pixel, then 2 pixels. And so every time, so its acceleration is half a pixel per second per frame. So that's acceleration. And if you think about it, we just set up gravity, right? So gravity, this is the force of gravity, just like 9.8 meters per second. This is the 5 pixels per frame. And this is gravity. And if you think about how jumping works, jumping means that we actually going to have a y acceleration in the negative direction because the screen starts at 0 at the top and the higher number 640 at the bottom. So if you want to go up, you have to go minus. So that's the little hint for how to do jumping. You're going to change the y acceleration in a negative direction. So the next tip I want to do before I stop the video and let you give this a shot is talk about how the cyclical motion works, this kind of pause state here. It's pretty simple math. This is, I don't really remember my trigonometry classes all that well, but I've just kind of internalized how sine and cosine work because I've had a chance to use them in my programming pretty frequently. But let's first start by setting up just the playing and pause states. We kind of did this with the previous example where we said if state is playing, we want to do one thing, and if it's not, we want to do another thing. So if it's playing, we want gravity to apply, and we also want to apply, the jumping behaviors, which is something I'll let you try to figure out on your own. But if it's not playing, we want to do something else. So let's make sure that this is wired up to do this. So I need to set up, so if game.state is paused, we wanted to set game.state to playing. So we can see it's paused right now because nothing happens in update. It is just going to continually draw the circle at the same position every time. And when we tap, the gravity starts being applied. So this branch actually comes into play. So what do we do here? Well, cyclical motion, again, uses trigonometry because that's how, because when you are moving in a circle, the sign of the number indicates the x position and the cosine of the number indicates the y position. I wish I had pulled up a GIF that I have that's really good for this. I'm going to search for it. So I found the GIF I was thinking of, doing a little Google searching. I think this is a pretty good explanation that takes a minute to kind of figure out what's going on. So we have this up here, theta, a symbol representing an angle. And you can see that the angle is going around, it's going from between 0 and 360, traveling all the way around the circle. And down here, we see drawing a green circle, and it's creating this correlation of the blue line is going left to right, so it's kind of the x direction of the point on the circle, and the red line has the y direction of the point on the circle. So if we look at cosine here, I think I switched that back and forth actually. Either way, if we look at cosine, if we take theta and we put it into cosine, when it's over here, it's farthest to the right, and when it's over here, it's farthest to the left. And then in between, it kind of has this nice natural movement where it actually doesn't go very far here. It slows down here and then speeds up as it goes a little farther. Just a nice natural way to create some motion because it kind of obeys the basic laws of trigonometry. So what you do is you take an angle and you put it into cosine or sine, and it creates these curves. So what we can do here is we want to change the y direction up and down based on a cosine of some angle. So what angle should we use? Well, it's arbitrary, it's a number. And so I typically create a property, some number, might start at 0 because it's easiest. And I'm going to change this number by a small amount every time. And this should be a pretty small amount, but we can play with this number. And then I'm going to change the y direction. I'm going to set it. I'm not going to add to it because it would just kind of go off into space that way. I'm going to set it, and I'm going to use cosine with that angle. Of course, this is not going to do very much. Actually, it set it way up here at the top, set to basically to 0. So I forgot what we actually want to do is take the middle of the screen and then add cosine to it. So it's right here, and it's technically moving, but it's not enough to see because one thing that this doesn't cover is that the sine and cosine of an angle will always output a number between 0 and 1. There's a unit. This green circle has the unit of 1, and 1 goes from the middle. 0 is in the middle, and 1 is at the edge because it has a radius of its unit. So this is actually, I was going to give you 1. So if we wanted to move by 20, we should multiply that number between 0 and 1 by 20, and then it'll go between 0 and 20. So it's now moving. It's moving very, very slowly. Let's bump up the speed at which the angle changes by a bit. Let's go 0.1. Refresh the page. Now it's going up and down. There we go. So that's the basic behavior. The two basic behaviors, in fact, the other one still works because if we tap, the game starts playing and gravity starts being applied. Don't have the jumping behavior though because I didn't do that code. So that's for you to figure out. Ended up doing more than I expected here, but see if you can figure out the jumping, and I'll cover the rest and do some cleanup in the next video.